topic for the talk, obviously, is where is the fall line? That is one of the questions that's asked almost every geology trip that I lead. People certainly know about the fall line, but many people seem to be very insecure about exactly what it is. So I'll try to clarify this to the degree that it can be clarified. So we'll start with the first slide here. It's not there. Okay. Okay, here we are. I downloaded this screen or this picture from a blog that's on the web. I've just simply put in fall line as a query, and this amazing picture showed up. It shows you exactly where the fall line is without any question. I think that you can probably guess that this is a little bit of an exaggeration. You cannot step from the coastal plain onto the Piedmont province across a dotted line like that in any real sense of the word. So what we want to do then is we want to try to work out what the fall line actually is, and then we'll appreciate better why the picture is a little bit silly. Okay, there is a historical fall line. When I was a child in Philadelphia, one of the things I learned in school was that Philadelphia was founded on the fall line. And then many of you that would be from the East Coast probably heard similar things about your area. But even this historical fall line is a little bit murky. And what I mean by that is the typical explanation given is that ships could go on rivers up to a certain point, and then there would be some kind of a blockage, rapids or waterfall, whatever. And somehow or other, this is supposed to be true of all these cities that are along the fall line. Now, as I said, I grew up in Philadelphia, and I asked my teacher, where's the waterfall on the Delaware that prevents the ships from going past the city? And of course, my teacher didn't know. So there is already a little bit of murkiness in this idea. That the basic idea is that the navigable ships of the colonial era would be able to travel upstream a certain distance, and then they would get blocked. Now, there is a city near us in which the city is really on what that idea of a fall line, and that's Richmond. I don't know how many of you are intimately familiar with Richmond, but I'm sure that you've all traveled through the city on I-95. So I'll try to describe its situation using I-95. Now, imagine that we're coming up I-95 from the south, from Petersburg, and we're coming into that stretch where going northward, you see the downtown buildings on a high bluff, okay? And there's a long bridge in front of that, right? Now, what you're doing there is you're crossing the James River. And if you were to look upstream, that is to the left, as you go across that bridge, you will literally see rapids. The river is unnavigable from that bridge, basically upstream, because of an extensive set of rapids. If you look downstream, there are no rapids. Now, as you get over to where you would be starting up the hill on the other side on I-95, you'll realize that to your left is the hill with the office buildings, and then to your right is a much lower area that's really below the bridge, or the causeway, whatever it is at that point. That is an area called Shocko's Landing. And that is actually the original city of Richmond. And it was built, it was established there specifically to be a port at the place where navigation was no longer possible going upstream. So Richmond is a perfect example of a fall line city in the way that the concept is usually explained. Now, my city that I grew up in, Philadelphia, as well as Baltimore, they're both fall line cities, but in neither case is there a waterfall that precluded anybody from going anyplace, at least in the port area. But in both cases, if you stand down at the water's edge and look to the north and west, you will be looking uphill and actually small streams coming down towards the Patapsco or the Delaware actually have cascades and waterfalls. So they are on a fall line, okay? For historical reasons or other reasons, the two cities were not literally built at the fall line the way that Richmond was, okay? So that's the concept of the fall line in terms of its history. We know the American Indians that were here before the European invaders were aware of the fall line, if not by that name, certainly as a landscape feature, because the present I-95 corridor actually follows the main Indian trails that went up the East Coast. The Indians, of course, did not have wheeled vehicles. They basically walked or ran on their trails. And even though they were probably in better physical shape than most of us are today, they still did not like to go up hills any more than necessary. And they certainly didn't want to be swimming across rivers. So what they did to follow the fall line was they placed their trail at a place that was just upstream from where all the embayments and estuaries and so forth were located, so that they wouldn't have to cross water somehow, but not so far upstream that they would be constantly going up and down hills. So they actually were very good at finding what the colonials eventually called the fall line. Okay, now let's go on to the next slide. Most of us are aware of the fall line as being the boundary between the coastal plain and the Piedmont regions. The coastal plain consists of layers of sediment. In our region, in the Mid-Atlantic region, the greater Chesapeake Bay region, let's say, all of those sediments, with minor exception, are marine. That is, the ocean was once higher relative to our present landscape. And all that flatness is basically former ocean bottom. Of course, it wasn't deep ocean. It was similar to what you'd get if you go off of the coast today at Ocean City or Rehoboth. Now, to the west and north of that coastal plain, we have the Piedmont region. The Piedmont region is underlain by very hard rock. The soil and softer material that you see on the surface is actually a chemical and physical degenerative product, a weathering product of that hard rock underneath. So if you could scrape away the soil and similar type material, you would have good solid hard rock under you pretty much everywhere in the Piedmont. Because of some uplift that's occurred in the not too recent or not too long ago geologic past, there's quite a bit of excavation by streams that's occurred in that landscape. So in general, the Piedmont is much more rolling and hilly than the relatively flat coastal plain. So from a landscape point of view, the fall line, once you're well into the coastal plain, well into the Piedmont, there's no problem telling which side you're on. Now, there is another fall line, in a sense, and that is a biotic one. This is a map of the EPA regions, what they call ecoregions, level 3 for our area. And you'll notice that from New York to Trenton to Philadelphia to Baltimore to Washington to Richmond and on down to Raleigh, okay, there is a boundary. And without getting too much into what the 63, 64, et cetera stand for, it's pretty obvious that at some high level, the vegetation, the prevailing vegetation to the east and south of that line is different from that farther inland. So even biologically, you can trace out a fall line. Okay. Now, if we look at the topography, it's a little bit more hazy in some senses, but if we look here from the New York area down across New Jersey, more or less along the Delaware River, the top of Delmarva, the northern end of the Chesapeake Bay, it's pretty clear that there is a bit of a rise where the Piedmont is out over here versus where the coastal plain is here. Now that's a little obscured there, but we won't go into why that's the case. But the classical fall line would go this way. Now, southern Maryland doesn't follow the pattern so well. It's not flat like that. It's a little bit more like the Piedmont to the west. And even some parts of Virginia nearby, and the northern neck, for example, are a bit like that. Now, that is a result of uplift in which the layers of the coastal plain there are relatively higher than elsewhere, and excavation by streams, erosion, okay, has dug into those layers. But even so, if you're familiar with Southern Maryland, there's large, basically flat areas that are similar to the areas over here, but simply lifted up higher. Okay, when we get down into more Southern Virginia, you get another clearer line there between the flat coastal plain and the rolling Piedmont area. Now, this diagram right here shows you in a very exaggerated way what this difference is. There are multiple layers of sediment in the coastal plain area that actually lie over top of the same kind of hard bedrock that's exposed in the Piedmont. This is typical of that fall line up there, that boundary between sedimentary layers to the east or south and hard rock underneath the weathered material to the north and the west. That is typical of this whole fall line area right here. Okay. Now, in detail, the real layers can get quite complicated, as is shown in that diagram, which even then is very much obviously a kind of a cartoon. But because of the land going up and down, the sea level going up and down and so forth over geologic time, there's complicated multiple layers of material in the coastal plain. But it basically all overlaps Piedmont rock that descends underneath it out to the edge of the ocean. So this is the physiographic fall line. And as I said, some places it's quite easy to see, other places it's more subtle. When you are on I-95, and then if you go on 495 up towards Philadelphia, if you look to your left, you can plainly see a ridge that marks the Piedmont boundary there, while everything to your to the right side as you're traveling north is as flat as a board. Whereas if we go to Washington, D.C., okay, right in about here somewhere, um, if you're standing like on Theodore Roosevelt Island, or actually if you're standing say at Iwo Jima, if you look out, you will see high areas to your north, east, and west, no matter where you look. And that's because, again, of that uplift of the coastal plain material that obscures the topographic difference through the central part of Maryland here. Okay. Now, a question you might have is this physiographic fall line, well, how long is it? And the short answer is it goes from basically Cape Cod all the way down into Mexico. There's some equivalent to the idea or to the situation of sedimentary layers overlapping onto hard rock. And again, all of that green area that's marked as the Atlantic plain on this particular map um, uh, essentially was at least at some point of its existence under the sea, under the ocean. So our fall line here is just a short section near its northern end of a much longer feature that, as I said, goes all the way down into Mexico. Okay, now we have this idea of a fall line being the boundary between the coastal plain and the Piedmont. And the reason that you have the rapids and waterfalls. Hello? Okay. The reason you have the rapids and waterfalls, okay, on many of these streams and rivers, okay, is that when streams cut down to go or descend down onto the generally lower coastal plain area, they typically cut into the hard bedrock and create waterfalls and rapids, basically where they touch, where their channel touches the hard rock underneath. Now, this map, which is a little bit odd looking, this is Delmarva, this is South Jersey, this is Virginia. It's oriented with the east at the top, and I did it this way so that you could see the coastal plain laid out in a nice fashion. And I want you to pay particular attention to the fact that the actual boundary between overlapping sediment and hard rock all along this coastal plain is essentially fractal. As you can see, there's little pieces of the sedimentary layering that are actually separate from the coastal plain, the main part of the coastal plain, and it doesn't show too well, but there's actually little pieces of exposed Piedmont that are surrounded by coastal plain material. The reason for this is that at some point in the geologic past, the layers of material being deposited by the ocean or by streams in some cases, okay, would have made a blanket with a relatively nicely defined edge to it, okay? All along here, and probably at different times, you'd have this sort of perfectly formed boundary between the coastal plain and the Piedmont. But all along the so-called fall line, there has been uplift of the landscape from tens to hundreds of feet over the recent geologic past, such that the Piedmont area is lifted higher than the coastal plain area. And so coastal plain layers have been worn away all along that boundary. And because nature doesn't act in real neat, orderly fashion the way that humans sometimes do, um, the actual boundary is extremely irregular, right? So given that situation, it's better to call the fall line a fall zone, okay? And geologists customarily do that. However, it's not caught on in popular usage, but if you try to think of a fall zone rather than a fall line, you won't be inclined to think that it's a dotted line that goes down the middle of the woods, okay? The basic difference between the basic characteristic of the fall zone is there's a transition from coastal plain type material, which on this map are these yellows and oranges and greens, versus the Piedmont basement rock, which in this map is the brown here. So, and then also this pink stuff. So as a rough approximation, the fall line on this map, which I think most of you will realize it's basically a part of Arlington, part of the district, the fall line in its traditional over-exaggerated way would be something like this, okay? But you have to realize that the boundary is fractal, and there's portions of the coastal plain material up going into the Piedmont, and then there's extensions of the Piedmont down into the coastal plain area. So the point is that this fall zone is a region, a band, a ribbon that extends across this whole area and should be considered to extend maybe 5 miles or so on each side of the closest line of division, clear line division between Piedmont and coastal plain materials. Now, I'm showing you this particular map just to show you how crazy it is to think of a fall line. The picture that I showed you at the beginning with the little dotted line running down was right there. Okay, now part of the problem here is that to say that that little dotted line is the exact place where the fall line is a little bit strange, because the Piedmont rock actually goes down underneath Theodore Roosevelt Bridge there to the other end of Theodore Roosevelt Island, okay? But a second thing that's even more egregious from my point of view as a geologist is that the brown material here is fill alluvium that the Potomac River has laid down. It dug a deeper trench during the times of the glaciers, so that the present channel, except rarely, doesn't actually expose the bare rock. Okay, there's a coating of river sediment, of alluvium. So that so-called coastal plain that was shown up there on the picture was actually Potomac River alluvium and not the coastal plain proper. So again, I just want to show you that however well-intentioned that idea in that first picture was not particularly helpful. Now, we've gotten this far, so I want to try to define the fall zone, and then I'm going to give you a little bit of example from Maryland how you would determine that you were in the fall zone or not. Okay, so in our local area, a 10 to 15 mile strip would encompass the boundary between the Piedmont and the coastal plain. And again, at any given spot, you can actually have um, an edge to the coastal plain sediment and a beginning of the Piedmont hard rock underneath. But the boundary is going to be extremely convoluted. So it's better to think of a band within which this transition occurs. In our general area here, the DC area, the Baltimore area, the bigger rivers and streams, and even relatively small ones, tend to cut gorges because we do have an elevation difference many times where the Piedmont's a little bit higher. And then also, and probably just as important, the coastal plain materials are very easily cut into. So as the stream gets closer and closer to the coastal plain area, it has no trouble removing that sediment. Okay, so it digs a kind of a ramp that comes from the general level of the Piedmont down to the coastal plain level. Okay, the bigger the stream, usually the longer and the wider the gorge. So I have a picture of the Potomac looking upstream from Chain Bridge. It's a rocky gorge that the Potomac has cut as it comes down from several 300 or 400 feet in elevation, much farther to the west, to almost zero elevation at about Georgetown. And it's a quite wide gorge, as you can see from the picture. Sligo Creek is an example from the Maryland suburbs of a smaller stream that has dug a similar gorge. If you go upstream from where this picture was taken, eventually the Sligo Creek will be a little bit of water that's kind of wandering around on a generally flat surface. And then very gradually it starts to dig a trench because it's going to be going down to Northwest Branch, which has dug its own trench. And that trench extends almost down to where Northwest Branch and Northeast Branch come together and form the Anacostia River. So the question then is, how do you know you're in the fall zone? Now, you cannot go to some particular place in our area and look around and say, oh, this is obviously the fall zone. It's really much more subtle than that. What you have to do is you need, but for one thing, you could use a map. Over here on the right side, the Maryland Geological Survey has very helpfully drawn a nice line here that is the center of what we're calling the fall zone. Okay, and you obviously could say, well, my house is here, so I must be on the coastal plain. But when I go up to Bel Air, apparently I cross through the fall zone. Okay, and you can say similar things about all the locations along that line there. Now, the way that you would determine in general whether you were at the fall zone or not is you would need a geologic map. You'd have to know your location. You'd have a geologic map. And on this map of Maryland, this generalized map, anything that's Cretaceous, Tertiary, or Quaternary, okay, which is the dark green, the yellow, and the sort of light beige, okay, is going to be coastal plain material. And then once you've defined where the coastal plain ends, which is the extremely convoluted line there along the green and the beige and so forth, then beyond that are older rocks, and that's the Piedmont. So then you say, well, I know where that line is, more or less, okay, convoluted as it is. So let's just imagine a band running through here, maybe 10 miles wide, and you can safely call that the fall zone. Okay, I think that's it.
Yeah, so if anyone has questions for Joe, you can unmute yourself and you can ask a question, or you could type it in the chat bar if you want. Is the fall line moving?
That's a very good question. Um, no one's ever asked me that before. um, yes, it is. Well, okay. At the moment, it's probably, to all intents and purposes, fairly stationary. What would tend to change it would be a new glacial age, for example, in which the water level of the ocean and of all the estuaries, streams, whatever around here would change. Um, if all the ice melted, then there might actually be some new deposits into what had been exposed Piedmont. So it will change over time, but it's not fast enough for us to really see it.
Is there, oh, what caused the uplift of Southern Maryland?
Okay, there's two things that go on over long periods of time. I'm talking about hundreds of thousands to millions of years. Um, One of them is a what's called an isostatic uplift of the former mountain ranges that were in our region hundreds of millions of years ago. When you have continental collisions, such as produce the Alps or the Himalayas, um, those mountain ranges, the material of it, actually goes farther down into the mantle than extends up into the atmosphere. And erosion quite quickly removes the high mountains where they form. Okay, the uplift has a limited lifetime geologically. Eventually, erosion takes over and will basically erase the mountain range. But now the balance of weight is out of kilter. There's too much um, light mountain material that's still buried beneath the site of the old mountain range. So there's a natural process where this very slowly lifts up. Um, an example of this today is in the Great Smokies. The Great Smoky Mountains, you may be aware, um, have multitudinous tiny earthquakes. And what's going on there is that the lighter weight material underneath that mountain range is jerking upward little by little by little by little by little, okay, with all these little earthquakes. And it's one of the few places along the Appalachians today where the net uplift that we can see going on actually counterbalances erosion. At the moment, every other place in the Appalachian chain, as far as I know, uh, we're losing material relatively because there's not an active uplift to counterbalance the erosion. Now, you don't need to worry about your mountain properties because the average erosion of a mountain range is on the order of millimeters uh, per, per million years. Actually, no, it's more than that, but more, like meters per millions of years. So it's not a very quick process. Okay.
Okay, the next question is there a fall zone equivalent on the West Coast?
No. The only, well, I'll take that back. There's a similar phenomenon that occurs around the Central Valley of California, for example. because the Central Valley of California is basically a filled-in inland sea, and it's surrounded on all sides except for the outlet through the um, out to San Francisco Bay. Um, it's surrounded on all sides by more or less hard rock. So if you were to follow any of the smaller streams up from the middle of the Central Valley and go towards the mountains at any hand, you would come somewhere to the first set of rapids, okay, where that stream was touching the bedrock. Now, you may be aware that in California, uh, there are so many dams now that it might actually be a little bit hard to find a decent stream for you to see this. But before all those dams and reservoirs were built, the bigger streams there would have pretty clearly shown the transition from the sedimentary area in the bottomland to the hard rock area, and there would have been a rapids or falls marking the spot.
Okay, the next question in the chat is similar to fall line moving, but is there still ongoing uplift along the coastal plain boundary?
My understanding is that the kind of isostatic uplift, okay, well, let me try. This gets really complicated because actually I didn't finish my answer before, because there's not only this isostatic uplift from the former mountain range, it also seems that in the mantle underneath the lithosphere, which is more or less crust in most people's terms, there's movement of plastic material. I don't want to say liquid. It's not magma, but it's like toothpaste. Okay, like extremely hot toothpaste. And there's movements of that kind of material underneath us that cause the different parts of the coastal plain over sufficiently long periods of time to go up and down on the order of feet to tens of feet. And in fact, that's part of the reason why southern Maryland is lifted a little higher than surrounding areas, is because of some of a phenomenon like that that occurred relatively recently. But then there's yet another reason for things going up and down in our area, and that is because of the continental glacier. The continental glacier never reached closer than about 120 miles from here. The nearest, if you wanted to go to the nearest place where the Great Glacier was 18,000 years ago, you'd have to go right up to Staten Island. And then that's would be the closest place to us here, where you would come to the edge of the glacier. But the great weight of glacial ice to the north of that caused this same kind of a plastic motion of mantle material to occur, such that it raised a kind of a rim around the southern edge of the glacier, an uplift. It was several hundred miles wide, extending from northern New Jersey, central Pennsylvania, down probably across most of Virginia and down into North Carolina. It got that width. And that particular glacial bulge, okay, reached its maximum when the ice reached its maximum, more or less. When the ice started to melt, the material started to move back to where it had originated, in effect, so that the bulge has been going down. but the ice melted much quicker than this bulge has been able to be erased by the movement of the mantle material. So there still is very slow drop occurring in our region as this glacial bulge disappears. And in fact, the amount of drop due to the dissipation of the glacial bulge is apparently about equal to the amount of ocean level rise in a world sense, that what's called the eustatic rise. So that the mid-Atlantic coast in many places is is dropping, so to speak, about twice as fast as the world average. And it's because we have this extra component of dropping.
Okay, the next question. Does sediment from the Piedmont get transported to the coastal plain, or is the coastal plain all sediment laid down from receding water?
That's actually a fairly easy question to answer, because any area that's above water, okay, so in this case, above the ocean, above the bay, above the levels of rivers, okay, is subject to erosion. There's no net deposition there. Now, the one exception would be along rivers where you have, like with the Potomac at Washington, where you have alluvium filling a depression, a floodplain. Okay, but in general, okay, with exception of the fresh alluvium being laid down by streams or in the bay, for example, around the edges of the bay, the coastal plain is eroding. And so therefore, there's nothing new being laid down on it.
Next question is, was the fall line at one point in time the coast?
At the height of the continental glaciation, which was approximately 18,000 years ago, the edge of the continent, the shoreline, was probably a cliff, and it was literally now you would go out on the shelf, and then you would start to go down the edge, off the edge of the continent. That the water went down enough that there was actually a cliff along the ocean side. So in that sense, anything other than the major rivers like the Hudson, Delaware, Susquehanna, which cut canyons down to the ocean and breached the cliff, okay, anything else would have come right up to the edge of the ocean and had a waterfall, basically. In that sense, the fall line did change, and relatively recently. We are pretty sure that there was marine material deposited probably at least the Point of Rocks, and maybe even almost the Harper's Ferry to Weaverton Gap or somewhere along in there, so that some tens of millions of years ago, perhaps, the equivalent of the fall line, the fall zone, would have been considerably farther west than it is now.
Cool. Next question, Joe, is the fall line in Mexico still associated with the Appalachian Mountains that are found there?
Okay. Let me try to answer this. It happens that that coastal plain with its fall line in the eastern part of Mexico to the west of the Gulf of Mexico. Okay, the continental area there is a fragment of the ancient continent in North America that broke away by plate movement and eventually docked to where it is now. And that is not really part of the Appalachians in any sense. The Appalachian system geologically starts at the very northern end of Newfoundland, comes down through maritime Canada and the southern edge of Labrador and Quebec, okay, down the what you think of as the Appalachians in the U.S., all the way down, and eventually sort of peters out in Alabama. And then there's another section of it that is in southern Oklahoma that's sort of isolated there. And amazingly enough, there's Appalachian type rocks in the Great Bend area of Texas. Now, in all these cases, there was in the long geologic past rifting and plate movements so that these pieces are not contiguous with each other anymore. Now, to give you an example, the break between the end of the Appalachian system in Alabama is actually the very northeast corner of Mississippi is where the Appalachian system ends. But there's a break then across the Mississippi Valley till you get to the Arbuckle Mountains and other things in Oklahoma. The continental area that had the ancestral Appalachians across that Mississippi Valley actually hundreds of millions of years ago was rifted out as a chunk of terrain, like Greenland, okay, a continental chunk. And because of the way that the ocean basin opened up with regard to that rifting, that piece of what used to be ancestral North America is now in northern Bolivia and the western part of Brazil, believe it or not. I guess I'm getting away from your original question, but the thing is that there's no part of Mexico itself today that's part of that that could reasonably be called the Appalachian system. You might be thinking of there are parts of Mexico that have Grenvillian rock. The Grenville orogeny was what created the southern part of Quebec, the Adirondacks, the southern part of Ontario, and parts of that orogeny are now located in Mexico. So that might be what you were thinking of.
Thanks, Joe. The next question is the unconsolidated material of the coastal plain turning into sedimentary rock? If so, how long will that process take?
Okay. It has turned into sedimentary rock in places. Now, if you take a cross section of the coastal plain, and that was hinted in one of my slides that I had there, it's actually triangular. It thins on the Piedmont side and is extremely thick on the ocean side. And the reason for that is that when sediment is laid down, um, as long as there's a continuing influx of sediment, okay, in general, the bottom of the pile has to keep dropping downward. It's kind of like loading a raft where you put material, or a canoe, you put more and more stuff in, and the bottom of the canoe or the raft settles down into the water. Okay, well, when the material, for example, that's going out into the Atlantic right now from the mouth of the Chesapeake Bay, from the mouth of Delaware Bay, from the Hudson River, and so forth, new material there is spreading out across the continental shelf. And actually, the continental shelf, the bottom of it drops down slightly to accommodate that. Okay. Otherwise, you would fill in the ocean. The seacoast would keep going farther and farther seaward, okay, because you would be filling up the narrow shelf there, the shallow shelf, okay. So this accommodation process occurs. So the coastal plain has been building for about 150 million years. The farthest out part, okay, out next to the ocean, in many places is on the order of 12 or 14,000 feet. Some places 18,000 feet thick. If you start at the actual edge where the coastal plain sediments literally border the literal fall line, where you cross from the coastal plain sediment over onto Piedmont hard rock, that's called a feather edge by geologists. From in our area, as you go towards the sea, okay, the pile of sediment thickens on the average by about 100 feet per mile. So, so by the time you're out in the middle of Prince George's County, you're probably talking about 500-600 feet. Anne Arundel County, 1,000 feet maybe, and so forth. Okay, and then this thickens out to the edge of the ocean. Now, anywhere where that pile of sediment is more than a few thousand feet, the sediment is now rock. Okay, and in fact, probably not even, you wouldn't even require that much to have a crappy kind of rock that didn't hold together too well, but still rocky type material. Most probably, in fact, almost certainly, those very deepest places out next to the actual ocean basin where material is piled up maybe 18,000 feet, the bottom of that pile is actually metamorphosed already. So, so yes, the rock is forming, and you would probably have to go down some hundreds to 1,000 feet at, say, on the eastern shore, and then you'd start to get definitely rock-like material. And the farther down you went, the more like real rock it would be.
Okay, the next question is, how do all the different zones affect weather patterns around the four-state area of Virginia, Maryland, West Virginia, and Pennsylvania?
Okay, okay, rather than say weather, I'll talk about climate. And if the person asking that question really wants to know about the weather, then I'll try to address that, but I can address the climate thing easier. In our general area here in the mid-Atlantic, we do not have enough relief, that is difference of elevation, for the climate to be mainly controlled by elevation. It's mainly controlled by latitude, okay? Then another important element is proximity to the ocean or the bay, okay? And then a third element is altitude. So generally in our area, as you come inland, you will be going from let's put it this way. Let's take the mid-Atlantic states, Pennsylvania down through Virginia. Okay, the warmest climate in that block of states, New Jersey, Pennsylvania, Virginia, West Virginia, and then the little things in between there. The warmest climate is Virginia Beach, which is the farthest south, next to the ocean at 0 feet. And then the coldest average climate is up in the northwestern corner of Pennsylvania, where there's some elevation. You're as far from the ocean as you're generally going to be in our area, and you're the farthest north. Okay, so the three zones these different physiographic zones don't control weather all that much. It turns out that a good deal of the difference of that biotic difference that makes for a kind of a fall line between the biotic provinces arises because the coastal plain generally is so much lower than any area to the west, and then also so much closer to water. So there is a kind of a climatic effect of a warmer climate that helps to produce the biotic boundary there.
Thanks, Joe. And we have one last question. Why is the coast north of Cape Cod so different?
Because the opposite effect of the glacial bulge occurred there. The weight of a mile or 2 miles of ice depressed the crust, and it has not finished rebounding. So what you have there is a drowned landscape. If you could imagine the sea rising 1,000 feet, okay, what the seacoast would look like in our area here would be very irregular with the Blue Ridge sticking up along the seacoast, all right, and every little hill and ridge, okay, sticking out in random ways, making all kinds of islands, et cetera, et cetera. Well, that's what's true north of Cape Cod.